Welcome to Principles of Macroeconomics. I'm your professor, Dr. Brandley Stitzel. First, I want to introduce us to a couple of ideas. The first is just what is economics? What is economics? Typically, if I ask this question in a class, I'll get answers like economics is about the stock market, or it's about money, or it's about businesses. And all those things are things that we study in economics. But really, what economics is about human behavior. Economics is about studying human behavior, choices, actions, incentives, etc. Specifically, the way that humans coordinate, right? How do they compete? How do they work together? How do we see coordination? Economics is built on two sort of subfields, if you will. These are praxeology. Praxeology is what it is we can learn about human behavior from things we know about humans. So this is not empirical. And then the other is called catalytics. Catalytics is the study of exchange. And so this is really a lot of times what we think about when we think about economics is when people transact, is when they make exchange, what determines those things. That's what economics is built on. So in this class, we're going to work on macroeconomics. Okay, so economics can basically, in the modern sense, be broken down into two things, and those two things are microeconomics and macroeconomics. Both of them sort of start at the market level, and macroeconomics aggregates up to the level of the economy, and microeconomics disaggregates down to the individual businesses. We often call them firms, and the households, how do households and firms interact. We're going to see lots of that in this class as well. We're going to have four sort of broad sections, categories in this class, and those are the fundamentals, just the fundamentals of economics, the tools that we're going to need to understand what's going on in this class. And then we're going to talk about measurement, because when we get to macroeconomics and aggregates, we have to learn how to measure the economy. So we're going to think about inflation, unemployment, growth, etc. Once we've got those in place, we'll really be ready to understand how economists model the economy. We build models that allow us to explain and explore what's happening in the economy. And then we're going to take that and we're going to make application out of them. And this is where we're going to get into a lot of those policy fields. We're going to talk about the Federal Reserve, monetary policy, fiscal policy, diagnosing, understanding recessions, things like that. Okay, so there's three big questions that an economy has to answer, and those are what to make, how much to make, and who gets what is made. Those are things that an economy is going to answer. Now, we run the risk sometimes when we're thinking about these kind of issues of thinking as if the president is deciding these things, and that's not true. One of the ideas that we really want to keep in our mind as we progress in this class is this idea of emergent order. And this is really a common topic in microeconomics, but it's just as important here in what we're doing in this class, because these things are answered emergently. What does emergent mean? Emergent means something that is happening because of human choices, but not from some overarching human direction, right? So what are some good examples of that? Language is a great example. People are making choices and adding words and trying to capture ideas or new phenomenon or new even new tools and new new practices and new institutions. All these kind of things have to be explained and described. Meanwhile, even words that we've used in one way in the past, or we'll even make nouns into verbs, things like this, all of these are choices that people are making, and we're using slang, or we're using words in new ways, or we're introducing new words into the language. Those are all conscious human decisions, but nobody's orchestrating that. Nobody's from the top designing that on its way down. There aren't languages that are designed like that. We do see some cases in like literature where really great authors like Tolkien have designed their own languages to use in the world, but languages that we see humans using are emergent, right? An economy is also emergent, and it will emergently answer these things. So how do we see an economy decide what it is that they're going to make. Well, the answer is, what is it that people want and need? So are things going to be made because the president sat up there and decided that something was going to be made? Of course not, right? It's actually much more interesting to think of what things are going to get made being determined by something like Shark Tank, right? And that's just really a showcasing of what's happening. But people come out of nowhere with these ideas to try to provide solutions to problems that they've observed or things that they think will make people's life better. And then, they go through this process of trying to get financial backing. Once we have ideas wherever they come from, right? Lots of businesses, people working out of their own, garage is like a common American stereotype of a new startup business, right? We then see how much needs to be made becomes a question of what does supply and demand in a particular market ask. And this involves a wide variety of things. I'm going to save that discussion for later. We're going to get into market processes. We're going to get into supply and demand. We're going to get into the role of prices. But this is also emergent. And of course, markets also answer the question of who gets what is made. All right, so a macroeconomy has sort of four broad categories of resources. This is like a classic out of your macroeconomic textbook section here. There are four resources. It's land, labor, capital, and entrepreneurship. Land represents natural resources. Labor, of course, represents the work that people put in and their ingenuity, etc. We might also refer to this as human capital in some places. Human capital will be a term that you hear that sometimes people that aren't in the econ field misunderstand and don't like. That means like education, intelligence, skills, things that are useful when it comes to producing things. When we say capital in this class, and this is really the reason that I keep this section in here, it's not that interesting of a dialogue, except that economics is like any other scientific field. We have to understand the language, the terms, the definitions, the lingo, the ideas in order to really excel in this class. You can't take a physics class and expect to pass if you're not understanding what force is, if you're not understanding the definition when your professor says gravity, right? You can't work in those fields. In the same way, we need to understand the terms that are being introduced in economics. For example, I saw a meme. Perhaps I'll put this somewhere in WT class so you can see it as well. And basically criticizing economists for using the ceteris paribus condition, which is all else equal, right? So these models that I'm talking about here, right? They're going to say, here's these behaviors, and when we see this happen, all else equal, we're going to see this other thing happen, right? So that is how modeling works. That's how modeling works in science, though. It's not as if economics invented this condition. What is it that a chemist does when they are trying to understand something? They hold everything else constant, and then they add their new compound in, and they see what the reaction is. If we want to understand how something affects somebody's health, right? We try to hold as many things constant and control as many variables as we can, and then we study the one thing, whether that's a medicine, an intervention, a food, even all sorts of things that we want to study. We try to hold as many things as we can constant. This is how science works. So economics, it is a science. Now, is it a science in the exact way that hard sciences are? No, obviously not, but we still want to have that same kind of idea of understanding the languages, holding things constant, studying different things that we're seeing happening. So that's part of why I keep this particular section in. And one of the main reasons is this word capital. So if I ask students in class, second day of class or whatever, when we're doing this in person, I say, what's capital? Of course, they'll say what's in your mind right now as you listen along. Capital is money, and that's because that's a finance definition, right? When we hear capital for a business, we usually think of startup money. But in this case, in economics, when we say capital, we mean tools. We mean tools. So what is the capital in a construction company? Well, that is the tools. That is the excavators, that is the backhoes, that is the bulldozers, right? That's like the quintessential. When we were all 5 years old, what we were thinking about was the tools involved in construction. Well, what are the tools involved in any number of other aspirations, right? If you open an artisan peanut butter jelly shop in New York City, what are your tools? Well, a butter knife to spread on spoons and your tabletop surfaces that you're going to be working on. These things are tools. That's your capital in this case. So when we say capital in this class, and we're going to say it a lot, so this is important terminology, we mean tools. We mean the things that you use to make other things. All right. Entrepreneurship then is a term that allows us to capture these other things that are happening, that are the risk-taking, the motivation, the vision, things that are going on in the economy that don't neatly fit into, especially the human capital section, but land or capital either. Let me go back to land just really quickly. When we say natural resources, when I say land, obviously you think of land in the definition that we would use it in day-to-day speech, but we also include a forest, minerals, a waterway, all kind of things are included there. All right, so let's turn now to a couple more definitions. In economics, one of the things that we're thinking about is efficiency. Okay, so what do we mean by efficiency? And this is a common straw man when we see people attack the field of economics, that econ is about efficiency, and what they think we mean in economics by efficiency is what it usually means in a broader like business sense. Like if you're taking other business classes, they'll say efficiency, and by efficiency what they mean, right, is doing things at their lowest possible cost, right? And that's what we call productive efficiency, right? And this is when goods and services are produced at their lowest possible cost. However, when we say that in a business class, we lose this idea of opportunity cost often in there. And this is fundamentally what is at play, but we have this sort of way that we associate that word with this cold mathematical efficiency and this impersonal. But actually what's happening here is it is fundamentally about value. It's fundamentally about value. Okay, so if I'm in class and I'm teaching this, I'm saying, what's opportunity cost? And I tell students, opportunity cost is the value of the highest foregone alternative. It's this simple idea that says resources can only be used in one way at one time, right? Your time can only be used in one way at one time. I'm here in this moment giving this lecture. What might I be doing instead? I might be answering emails. I might be giving a lecture in a different class. I might be going to a meeting. I might have any number of things that I could be doing. Whichever of those things has the highest value, the highest productive value, or really when we think about the word value in economics sense, we're talking about something that is specific to whom it would have value for. Okay, so a good example of this, I'm here recording in my office and I'm recording on a microphone, and therefore that microphone has certain value to me. It's allowing me to do things, specifically to produce this lecture at this time, and so it has a certain value to me. Now some of you listening along would have no use for a microphone, right? So this value that the microphone is providing me doesn't provide you any value. You don't have anything that you need to be recording or allowing people to hear your voice online, so you don't have use for a high quality microphone. Now some of you might actually have a use for a microphone, right? You might be recording your own videos or podcasts. You might be streaming things online, any number of things that would be useful for you to have access to a microphone, or even simply being in an online atmosphere where you're FaceTime, Zoom, etc., and a microphone would be something of use to you, right? And we'd all have different values based on those different uses, right? So opportunity cost then is whatever it is that the resource would be doing or that the individual would be doing instead of the current application, and therefore that value is foregone. If I weren't recording this lecture, if you weren't listening to this lecture, what would we be doing, right? Well, perhaps I'd be answering emails. My opportunity cost of recording this lecture then is the time spent answering emails. Perhaps if you weren't listening to this, you would be eating lunch, or you would be spending time with friends, or perhaps you would be working on other classes. Whichever of those things has the highest value, that's your opportunity cost, right? So why is productive efficiency so important then? It's not a cold, impersonable, amoral sort of thing, right? It's saying productive efficiency just doesn't care about people. Well, actually, fundamentally, productive efficiency is built on lowering the opportunity cost. We want to reduce the amount of value that people are having to forego, right? And so if you're in a situation where you're having to give up a lot, then the opportunity cost is very high. So producing, now let's turn this back towards resources in the way that we think about productive efficiency. Although people's time is one of these resources, right? Remember, labor was on the last page. That is in play here. And so if we have two uses for a piece of wood, for example, I teach sports economics, and in that class we might talk about baseball. Baseball bats are made out of wood. Another use for wood might be to build houses or to build furniture, right? How do we know which of those things we should use that lumber for? Well, the answer is which of those things has the lowest opportunity cost. We want to reduce the amount of value foregone in that alternative situation. And so productive efficiency is very good because it reduces the amount that people are having to give up in value in order to get what is being produced. Now, there's another type of efficiency called allocative efficiency, and that's when the mix of goods and services produced is what society wants, right? And so it's wasteful if we go and take resources and produce things that nobody wants, right? We can all think of various products out there that seem silly to us that we would never want. I always joke about like Crocs or something like this, but many people love those. How many of those should we have? If we have too many, it's wasteful. If we have too few, it's also wasteful, actually, right? Because then that's value that people could have had that they don't end up getting. And so you don't want to make me a pair of Crocs, but perhaps if you, the listener, is somebody who likes those as shoes, then we would like to have a pair out there for you. That's allocative efficiency, right? So it's not a all or nothing situation. It's a how much of this should we have? How many things, how many resources should we devote to producing a particular item versus a particular service versus how many of those things should be produced? Okay, let's turn now to the simplest model of the economy, and that is the production possibilities frontier model, or the PPF model, Okay, so simple assumptions that we've got here is we're taking one country. This one country is producing two goods, right? So simplest economy we can have, one country, two goods. Let's say in this case that it's producing batteries and it's producing flashlights. Okay, any example that I pick here is going to be silly, right? Economies have to be producing a wide variety of things, but we're really going to be able to expand this model if we needed to include more goods, and in fact, obviously we will over time. But all I want to show us here is, let's put flashlights on the y-axis and let's put batteries on the x-axis. I just want to demonstrate this model and how we get back to that idea of opportunity cost. Okay, so point number one, so possibility production frontier, possibility, or point one, point literally in a two-dimensional space, right? Point one says we have 0 batteries and 30 flashlights. What does this teach us? Well, this teaches us something actually very important. If we have 0 batteries, we can use all our resources to produce flashlights. We'll be able to produce 30 flashlights. Okay. Now, if we want to produce some batteries, as we do at point 2, then we must by necessity be taking resources that would otherwise be spent producing flashlights, right? This should make some real sense to us. These are exactly these ideas that we were just talking about. There's opportunity cost. If I produce one battery, now that I'm looking at it, it doesn't make a lot of sense that we're producing so many flashlights and so few batteries, but bear with me, the math will work out in the end. Or we can even swap it here. I'm going to go ahead and move these around so that they make more sense to us. Intuition, although it's just an example. Okay, so if I want to produce a flashlight, I'm going to produce fewer batteries, right? So I come over here and I say at when I produce one flashlight, right, I'll only be producing 25 batteries. And this process continues, right? What if I want to produce one more so that I have 2 total? I'll be producing 2, and that'll give me 20. And then I want to produce a third, and that'll give me 15. I'm going to produce 4. I'll only be able to produce 10. And then if I produce 5, I'll be able to produce 5. And as we see here at possibility 0.7, if I want to produce 6 flashlights, I must divert all my resources in the economy to do that, and I won't be able to produce any batteries. Okay, so why is this model called the possibility production frontier? Okay, what I'm saying is this is the set of all possible production choices, and this right here, that line, is the frontier of that. Just another way to say the boundary, right? Okay, so let's look at some potential cases, okay? So in my economy, what if I want to produce 3 batteries and 15 flashlights? Can I do that? Well, if we come over here and we look, we see that when I produce 3 batteries, I can also, 3 flashlights, I can also produce 15. So this is possible, right? This is possible. And in fact, it's not just possible, but it is also efficient, right? And the reason it's efficient is because it's using all of the resources to produce what we have in the economy. What if instead I wanted to produce 3 batteries and 20 flashlights? 3 batteries and 20 flashlights. Okay, so when I choose to produce 3, I keep labeling these backwards. My apologies, guys. I mean, obviously that combination would be another combination we could also consider, but it's less interesting. Flashlights, batteries. In this case, where would we see this on the graph, right? Well, 3 and 20 would be out here. This is what we call impossible. So one of the questions we want to ask is a particular combination of goods or services that we're producing, given the set of resources that we have, right? So I've introduced 2 ideas, resources and efficiency. I've combined them into our simplest model of the economy. And that turns out to be a point that is impossible. Okay, well, the listener here are quite smart, and so you can anticipate exactly what I'm going to do next. What if I want to produce 3 flashlights and I want to produce 10 batteries, right? Well, what does that look like? If I want to produce 3 flashlights and 10 batteries, and I'm now inside of the PPF, the production possibilities frontier, this is certainly possible, right? It's possible, but it doesn't make use of all our resources, and as a consequence, it is inefficient. Okay, so a couple of ideas. I'm showing you efficiency. I'm showing you resource use. I'm also showing you opportunity cost. How do we see that? Well, as discussed, right, if we move from point 1 to point 2, we go from producing 0 to producing 1 flashlights. We, by necessity, lose 5 batteries that we could have produced. We had to give up something in order to get something else, right? Basic opportunity cost idea. That's cost, right? I mean, you understand that intuitively yourself as cost, right? And we're saying your opportunity cost to go from point 1 to point 2, producing 0 to producing 1 flashlight, is you give up 5 batteries. That's an opportunity cost of 5. Now, in this particular example, it'll be 5 all the way down, right? Because it's a straight line, the opportunity cost is everywhere the same. This really highlights that big idea that we've introduced that's going to be with us the whole semester of opportunity cost. Okay, let's take some examples now of ways that this model can teach us and show us some things. Let's look at an example where we're going to have this opportunity cost. Now, in this case, we're talking about a marginal cost. And margin means, so when we use the word on the margin in economics, we're talking about the next unit. In fact, let's write that down because this is an important thing for us to remember. Marginal cost, that's the cost of the next unit. So anytime we use marginal, we mean of the next unit. The next unit, okay? So if I'm at point 1 and I go to point 2, that's on the margin. If I'm at 2, I go to 3, now the third one is the margin, right? So that's what we mean by we're saying we're on the margin. But let's take some examples here. Okay, what kind of resources go into producing cars, and how similar are those to producing bicycles? Well, there's similarities, right? You're producing things with wheels, you're using metal alloys, you're using rubbers, you're using plastics, etc., right? So these are, in the end, somewhat similar things to produce, okay? So the opportunity cost is similar if I'm all the way on one end, right? So if I produce no bicycles and I produce all cars, maybe I can produce 100 of those, right? It's going to be a constant marginal cost all the way to the other end of the spectrum, where, of course, bicycles, for every car I could produce many. So let's say there's 10,000 bicycles that I can use, right? The constant marginal cost doesn't mean one-to-one. It just means that everywhere along this line, the marginal cost ends up being the same, right? Because when I take somebody who's good at making cars and I have them make bicycles, that's going to be a pretty small loss for them. They're going to be able to do that somewhat reasonably well. When I take metals, when I take manufacturing plants, the production process is very similar, right? So here I'm really talking about the production process, and the similarity between them is what determines the shape of the marginal cost curve. Okay, so that doesn't make a lot of sense to us just yet. Let's take an example of what we call increasing marginal cost to help us understand this idea. What if I, instead of producing things that are sort of similar, cars and bicycles, I produce things that are very different, let's say phones and wallets? What do phones take? High technology, plastic, glass, metal, computer chips. What do wallets take, right? It's craftsmanship, it's leather working. I have to have leather, I have to have thread, I have to have sewing machines. The processes are very, very different. If I take all my resources and I put it into making phones, and let's say we can make 1 million phones, all right? Or I take all my resources and I pour it into wallets, and let's say we could make 1 million wallets too. Why not, right? What does it look like moving from one point to the other? Because we know it's not a straight line, what we'll see is a curved line, And this is important because out here in the middle, right? And of course the curved line doesn't have to be as centered in the middle as I've drawn this particular curve, right? But some resources are very good at making phones. Okay, I get a software engineer. He's going to be very good at making phones and very poor at making wallets. If I get the word for somebody who works leather is escaping me, but I guess somebody who's good at working leather, and then I ask him to make phones, he's going to do a poor job, right? Which means as we move away from center, we're actually going to see the trade-off between the two things change, right? We're actually going to see the trade-off between them change. And this is what we call increasing marginal cost, okay? So here in the center, right, I've got leather workers working on leather, and I've got software engineers working on phones. I've got manufacturing people working on phones. I've got people out in the pasture raising the cattle so that we have the leather to make our nice leather wallets out of, et cetera, et cetera. Now, for whatever reason, my economy decides we need fewer. Let's just take a look at this real quick, actually. So this optimal combination might be like 750,000 of each, right? And as we move, we say, okay, we need more wallets. So we're going to move, we need more phones. We're going to move this way. We're going to give up lots and lots of wallets in order to make relatively few phones. Why? Because now here in the center, it'll be closest to the straight line. And actually, let's draw the straight line here. Let's draw this so we can kind of visualize. I'm going to make that intercept right there at that point. So you can see the one-to-one trade-off is closest in the center, right? The slope of the curved line, the pink line, is closest to the slope of the white line there because the trade-off is the closest. The further we move away from the ends, let me erase these two so we can see a little better. The further we move away from the ends, the less our curved line begins to look like the straight line, right? Because when I'm here, there's somebody out there who is pretty good as a software engineer and in their spare time likes making wallets, right? Or there's somebody out there who's looking for a career change from one to the other. And so when I move a very short distance either direction, the trade-off is pretty small, right? But once I'm over here, right, let's say I'm at this point now, right? I'm at this point. So I've given up a lot of wallets in order to produce a few more phones. And the trade-off's not too bad initially, right? Trade-off's not too bad initially. And we're looking at something like, I don't know, whatever, 850, right? If I want to then move from this point further along the curve, now there are fewer and fewer resources and fewer people who are good at making that transition. And I will give up a lot. Maybe this is 250 in order to just get a few more phones made, right? So maybe we only get 900. Like obviously you can see that's how that slope would work out. This is this idea of increasing marginal cost. And probably most goods and most things in the world, the two things that are going to be related, we're going to get this kind of relationship. Okay, now once we've got a nice model, we can look at situations that highlight how we can use this model. Okay, so let's say that we're going to make pizza, and we'll make let's make this first one a near constant, right? So pizza and, I don't know, calzones. Those are the only two things our economy makes. Apparently we only eat Italian-inspired dishes. That's going to be a straight line, right? These are like very, very similar, products, right? We got pizzas and we got calzones. Now, along comes something in the economy that affects our production of pizza and doesn't affect, either way, affects our production of pizza and not calzones, or calzones but not pizza. It affects one or the other, right? And so what would be an example of this? Well, if it were ovens, it would affect both of them, and we'd see a shift, right? If it were ingredient related, it'd probably affect one or the other. But let's say somebody comes up with a brilliant new technology. It's a technological change, but it's in terms of how we fold calzones together and flip them. I don't know. It's a spatula invention. Will that change the amount of pizza that we are able to produce? Obviously not, right? And so that will stay the same. Will it change how much we can produce calzones? Yes, we're now more efficient in producing calzones, and so our production possibility frontier looks like this. We're getting an outward rotation. Now, let's do a little bit of analysis now that we're here. Okay, if in situation one, we're producing 100 of each, let's just keep the numbers easy, right? What is the outcome from technology that benefits one in particular and not both? Well, you would think we just get more calzones, we wouldn't get any more pizza, right? But this is obviously not how this is going to work out, because what would be the most likely, given that in our current economy we like this combination of these two things, what are the three things really that could happen? Well, one is we could hold the amount of pizza that we make fixed, and we can make 125 calzones. But we could also just as easily more efficiently produce calzones, but then shift more resources towards making pizza. In this case, this is a very straightforward trade-off, right? Alternatively, right, we could do some of both, and we could end up, because of our new technology, we could end up producing a few more of both. I'm not going to try to do, well, I guess I can do the math exactly here. And we could end up with more pizzas and more calzones. So here's one of our first lessons from why is a model so important in economics. It allows us to use tools of analysis and to draw conclusions, right? And that is technological improvements in one resource can actually benefit other resources that also exist in the economy. Now, in this case, I made the example nice and clean, pizzas, calzones, like the trade-off is obviously nothing, etc., right? But this truth also applies to many other things. Okay, now let's think about some examples that would show us what would happen with a shift instead of a rotation. And so in this case, let's take making cars and computers. So the two things that we produce in the economy are cars and computers. What does the shape of this look like? Well, obviously it's going to have increasing marginal cost, right? And that's because we have to have manufacturing to make cars, and we have to have different kind of manufacturing to make computers. You know, these are kind of somewhat related. This is a really probably nothing is a truly straight line. Everything it does have some kind of I mean, maybe my pizza and calzones example is one of the few that would really have a straight line, right? But these are going to have increasing marginal cost, right? Because you're going to be manufacturing quite differently. You can imagine basically every manufacturing process is going to be quite different, okay? And here in this case, right, this allows us to make 100 million cars and 200 million computers, whatever those numbers are. But then something happens in the economy. Let's think back to those resources: land, labor, capital, and entrepreneurship. Which of those things would like really impact both of these economies, right? Well, let's say it's something related to education, right? And we're able to really produce productive workers, high education becomes more affordable, more widespread, more high quality, right? So it makes some breakthroughs. Maybe this is online learning, I don't know. Will that affect car production? Yeah, absolutely, right? Because we're going to have better educated people. We're going to have people in there that are going to understand manufacturing and supply chains better, right? It's easy for us in a college of business like we are to think about ways that would work out. Is that going to affect computer production? Obviously, right? Because we're going to end up having more people that are going to be better software engineers that come up with great ideas. We're going to produce more of them. They're going to be more high skilled, etc. And so that results in a shift. So it's just a straight line outwards, right? Straight line outwards. Now, what's the outcome? Now, this is less interesting, right? Because in this case, your intuition would be that, right, if we were producing 100 of these and 50 of these, really it would be quite a bit more, right? So let's just say 75 of this. We could, just as before, produce the same number of cars, produce more computers. We could produce the same number of computers and just produce more cars. Most likely, though, we're going to get this outcome, right? And we're going to produce a lot more computers, but we're also going to produce a lot more cars. Okay, so that's shift, that's rotation. This is how we think about those things. So what's this going to look like on an exam or quiz, right? It's very straightforward. You're going to be asked what happens in this particular economy. Consider an economy that we make buses and rain filters. And now imagine a situation where the availability of tires being produced goes way down in economy. Analyze. This is the kind of analysis you're going to do. Okay, let's turn our attention now to absolute and comparative advantage. So absolute advantage is the ability of an actor to produce more of a good or service than a competitor given the same resources. Just literally, if you're comparing two people who can produce more, if you give them the same thing, right? So if you put me on a basketball court with Steph Curry, you give us the same number of basketballs, and we engage in a three-point shooting contest, who's going to make more baskets, right? If you give a carpenter and a non-carpenter the same tools and the same workspace and the same amount of lumber, who's going to produce more or better chairs, right? Okay. Comparative advantage, though, is the ability of an actor to produce a good or service at a lower opportunity cost than competitors. So this means what they're foregoing by doing what they're doing costs them less than their competitor. Okay, let's see that in action. So let's do some examples here. A straightforward example. We've got Ben and Jose. They're stranded on an island, right? And to survive, they end up needing to eat, and they need to be able to drink water. So they got to have food and water, and they're gonna eat fish because it's an island, obviously. So they're gonna have to engage in fishing to catch fish in order to eat them, and then they're gonna have to collect wood in order to boil the water to do so safely. Okay, and in this situation, what happens? Well, Ben can spend a day working. He can catch 6 fish, or he can gather 10 pieces of wood. Jose, spending the same day, can catch 8 fish, or he can collect 10 pieces of wood. When we've got this information here, we can already figure out what the absolute advantage at play is. So who has the absolute advantage in this case of gathering or catching fish? Well, we can see that that's Jose, because if he's given the same amount of resources, in this case, same fishing pole and same amount of time in the day, he'll catch 8. Ben will only catch 6. On the other hand, what if we, same conditions, want to compare their ability to gather firewood? We'll see that it's Ben that's higher that. Okay, now that's absolute advantage, very straightforward, very intuitive, but what we need to understand though too is the comparative advantage. The comparative advantage, and remember that is the opportunity cost. So how do we figure that out? Well, for Ben we have a simple situation. He can either spend his day catching 6 fish, or his day picking up 10 pieces of wood. So what's his opportunity cost for catching a fish? Well, that is going to be 5/3 of a piece of wood that he forgoes for every fish that he catches. And of course we can do the exact opposite, right? What if he gathers a piece of wood? It's going to work out every time to be the exact inverse, but I'm going to show it to you, right? Oh, excuse me. 6 fish, 10 wood, 3/5 fish. Okay, so let me highlight these just a little bit for you. That's what we're looking at. Now, in order to compare them, as we're going to do with comparative advantage, we need to do the same for Jose. We made Jose's math easy, so I'm just going to do it once. Every fish that Jose catches costs him 1 piece of wood, and every piece of wood that he picks up costs him 1 fish. Because as we see in just his production, the point is Jose is equally good at fishing and catching wood. All right, so the question then, who has the comparative advantage in fishing? Who has the comparative advantage in fishing? If Ben catches a fish, he forgoes more than 1 piece of wood. He forgoes 1 2/3 pieces of wood. If Jose catches a fish, he gives up 1 piece of wood. So who has the lower opportunity cost? What would be the productive efficiency here? Well, in this case, it's very straightforward to see that that would then be Jose. Now, what if, and what's the comparative advantage for picking up a piece of wood? For Ben, he gives up less than 1 fish. And of course, as we know, if Jose gathers a piece of wood, he gives up a fish. So he's relatively a better fisherman compared to his ability to gather wood than is than is Jose. And so Ben is going to be the comparative advantage here. All right. So that's a very straightforward example. Let's turn to an example that kind of drives home the differences between absolute, right? So why did I say that's straightforward? Because these two are exactly the same, right? Because we just clearly see Ben is not as good a fisherman, but he's a better wood collector. So the comparative advantage is exactly what we would intuit. So Jose escapes the island. For whatever reason, Ben doesn't, but our poor guy Cain, he gets stranded. So Ben is exactly the same as before, but Cain comes along and he's just a savant at gathering firewood, right? So let's do the analysis. Absolute advantage. Absolute advantage. Who has the absolute advantage in fishing? Well, we see that it's Cain, right? Because he can catch 8 fish in a work day, whereas Ben can only catch 6. So who has the advantage then in gathering firewood? Well, remember, Cain's awesome at this, right? He's twice as good as Ben. Cain has the absolute advantage in both situations. The absolute advantage in both situations. So should we then just infer here to here that these should be copied just as before? Well, actually no, and that's because of opportunity cost. Cain can only spend any one given moment gathering the wood or catching the fish, so we know that he's going to have opportunity costs related to those. If you'll remember, right, we've already calculated those for Ben, so it's relatively straightforward, right? His fish is 5/3 for a piece of wood, and the wood that he gathers is, of course, 3/5 fish that he gives up. Okay, so what about for Cain? Well, for every 8 fish that he catches, he could have spent that same time gathering 20 pieces of wood, and vice versa. So let's calculate. Very straightforward, right? Oops, 5/2, excuse me. So we took 4 out there. Pretty straightforward, right? Just like, I don't know, 6th grade level arithmetic there. And we can do the reverse, of course. I'm going to show it to you, but when you actually do these for the quizzes, what should you do? Once you calculate one of them, you just flip it over because that's all we're doing here. All right, so actually let me rewrite these just so it's easier for us to follow. I'm just going to simplify. Just going to drop that math out of there so we can compare directly. Like so, okay? Like so. Okay, so who has the comparative advantage in fishing? Who has the comparative advantage in fishing? Well, when Ben goes to fish, he gives up 5/3 piece of wood. When Cain does it, he gives up 5/2 piece of wood. So what does this translate to? We already said it. 1 2/3. What does this translate? 2.5. Cain is so good at gathering wood that even though he's a better fisherman than Ben, when he goes fishing, he could have gathered much, much, much more wood. So the comparative advantage here actually goes to Ben because the amount that he forgoes in the firewood that he picks up for catching a fish is much less than how much Cain forgoes when going through and catching a fish. And then, of course, straightforward, right? What did I do here? I apologize. Some typos here for you guys. When Cain goes to gather a piece of wood, he doesn't give up nearly as much when it comes to gathering wood in terms of catching fish. Okay, so Cain has the comparative advantage. Now, unless your ratios are exactly equal, then we know whatever it is, you can only have comparative advantage in one thing, because anything that you're really, really good at means doing other things, you're foregoing lots of what you're good at doing. Okay, so this actually has a lot of lessons for us in terms of how we understand how we should interact in an economy. Okay, so now let's take a look at Ben and Jose if they spend half a day on each task um, versus if they spend their full day doing each task. Okay, so let's review. So if Ben and Jose spend half a day doing each task, that was the ugliest arrow of all time, right? 6 and 10, 8 and 8. So come back over here. We remember that Ben's going to do 3 and 5, and Jose 4 and 4. How much total are they going to get, right? They're going to end up with 7 fish and 9 pieces of wood. What if they focus on their specialization, right? They focus here, right? So Jose does all the fishing, and Ben does all the wood gathering. What are they going to get? Okay, so Ben's comparative advantage is with gathering wood. So he'll do no fishing, but he'll be able to gather 10 pieces of wood. Meanwhile, Jose won't spend half a day gathering wood, so he'll be able to catch 8 fish. And we see that they'll have an extra fish and an extra piece of wood. Now, what's the problem? What's the problem if they stay here? If they did this but they didn't know each other? Well, Ben will starve to death because he doesn't have any fish, and Jose will die of thirst because he didn't gather any lumber to purify the ocean water and get the salt out of it, right? So what they really need to do, they've specialized. This is the beauty of it, right? That's what I'm saying. The comparative advantage really tells us is about specialization. But in order to survive, they have to trade, right? They really, really need to trade, right? Okay, so let's take a look at how that would work out. Now, what would be an obvious situation here, right? Jose could trade 4 fish to Ben and receive in exchange 5 pieces of firewood. Now, we could do any number of things, right? He could instead, like an alternative situation, he could give him just 3 and keep 5 to himself so that he has more fish, right? And Ben could keep 6 and give him 4 or whatever, right? And we can see that in either scenario here, Ben's better off, right? Because either he has more fish and the same amount of wood, or he has the same amount of fish and more wood. Either way, it's going to work out great for them. I'm going to erase that because I don't want you guys to be confused by that. There's any number of good trade outcomes, right? We could even have wood and fish would both be things that we could have. So you could have half of each. More. The point is that they benefit from trade. Okay, this is a really, really important insight. It's a really important insight because what we're saying is by doing nothing other than specializing and trading, both parties are made better off, even though they didn't get better at fishing, they didn't get better at collecting wood, they didn't introduce new technology, they didn't spend more time doing it. I'm saying they just spend one work day doing it. However it is that we want to qualify that. There's no more resources, there's no more effort at play, but by specializing in trading, we can see that people benefit. Okay, so now let's do the same thing. It's half an hour here. It should be a day. Half a day. What do Ben and Cain do? Okay, so 6 and 10, 8 and 20. So Ben is again 3 and 5. This is 4 and 10 for a total of 7 and 15. Now, what if they specialize? Now, here it gets a little more tricky, right? It gets a little more tricky because maybe what would happen is if Ben focuses on just fishing in this case. Cain, remember, was providing some of the fish in this case and some of the wood. And so if Ben focuses on it, he can't by himself provide 7. Remember, we said well, let's just copy this over so that we can keep track of this more easily. Right? He can't provide that on his own. They're only going to end up with 6 in this case if they specialize. Okay, so just because we specialize, now Ben is going to specialize in this case, right? He is going to specialize. He's going to say 6 and 0, right? Because he does not have the absolute advantage in either situation. But if they still want 7, what is Cain going to have to do? Well, Cain's going to have to still collect some in this case, right? Still collect some. And so he's going to go through and say, let's say he gets 2, right? And we remember what's the trade-off for Cain. So if he goes and collects 2 fishes, he's going to give up actually 5 pieces of wood, right? And so here we'll see that he'll only collect 15. So I made it this way because obviously the math works out really easy. And you can see that in this situation, they have the same amount of wood as they did before, but they've managed to gather another fish. And this is because in this situation, they have the absolute advantage, but we have to end up engaging in a particular kind of specialization, because Ben is going to be able to specialize in one thing and really put his best foot forward, his most productive, his lowest opportunity cost, and then because they don't want to end up with fewer fish. Now, notice that they might be okay with ending up with fewer fish. That's allocative efficiency, right? But here, for mathematics' sake, I want to show you what specialization and trade ends up looking like. So what might this look like when they actually go to specializing and trading, right? In this case, we could see 4 and 4, right? Or maybe Ben could trade away 3, right? Ben could keep 3 and trade 3, so that Cain ends up with 1 more fish than he had before. But in exchange, he could get, I don't know, it doesn't matter, 7. Well, it does matter in this case because he's going to get 5 and 15. Okay, what's an alternative way they could trade, right? They could go 4 and 4 for 5 and 15. There's lots of, I'm sorry, I wrote 15, but I meant 10. Any number of combinations here, right? So there's no like one, there's no one right answer here. There's no one particular right answer in how the trade part of it works out. There's no one particular answer in how trade works out. Okay, so what this really highlights is the importance of trade. So what's trade? Trade is very simple. It's just the act of buying and selling. In a direct trade, this means a one-for-one swap, and this requires something very important, which is different evaluations of the same thing, right? So I have a lawnmower, you have a set of golf clubs, I'm getting into golf, your lawnmower recently broke, you'd like to mow your lawn, so now I have a higher evaluation than the golf clubs than you do, you have a higher evaluation of the lawnmower than I do, we make a swap. The important thing about this, and one of the critical things in economics, is when we see people engaging in trade, it's by definition mutually beneficial, because you didn't make a trade that you thought would make you worse off. You made a trade that you thought would make you better off. You know, obviously, saying absent coercion in this case. I'm talking about free trade, both parties, nobody was forced into it, right? Now, there's another type of trade, and that is indirect trade, right, where you trade labor or other resources for income, and then you take that income and you trade it for the goods and services that you want. This is mostly what we engage in today, right? We work, we get some income, we take that income, we purchase things, right? Probably I'm not going to swap a lawnmower for golf clubs with my neighbor, but, you know, I might see that he has golf clubs that he wants to get rid of, give him some money, and then he might take that money and go find somebody else who, you know, has a lawnmower at their garage sale, and now we've engaged in indirect trade. This is really important because it makes it possible for people to become better off by increasing both their production and their consumption through specialization in a way that benefits them because it's mutually beneficial exchange without having to bring other resources to bear, right? If we just get better at doing something, that benefits people, and we saw that in our possibility of production frontier curve. But specialization and trade is very important because without bringing more resources to bear, we're able to mutually benefit everybody involved in the transactions.